Hey guys, we're going to jump right into lesson 4.6. Let me present my screen and we'll get started. Okay, so for this lesson, we're trying to find the zeros of the polynomial function. I kind of skipped over the terminology. A lot of this we've already used in previous lessons. I'm going to jump right into the problems today though. So to find the zeros of the polynomial function, we usually set it equal to 0 and we see if we can factor. However, if you're given a polynomial function that can't be factored, that's when we're going to use the rational roots theorem. So a few things to just notice here is that since this is a polynomial with degree 4, I should have 4 solutions. Okay, so keep that in mind as we go through the problem. Since there are 1, 2, 3, 4, 5 terms, I know I'm going to use the rational roots theorem, and that's that whole P over Q thing. But remember I told you we're going to use our graphing calculators to figure out what values we're going to test. Okay, we're going to plug this function. We're kind of cheating a little bit. We're going to plug this function into our graphing calculators, graph it, and see what the x-intercepts are. All right, so let me pull up my graphing calculator. Pull this over here, y equals, clear this out. All right, so I have x to the 4th minus 3x to the 3rd plus 6x squared plus 2x minus 60. Oh, not 61, 60. 60. Okay, I'm going to graph it. All right, I can see it goes through the graph at 2 spots. I'm going to go to the table of values. I'm going to look for what x value has a y value of 0. So -2 and 3. Okay, so -2, -2, and 3. And you get to pick. You can pick -2 or 3 to do synthetic division with. All right, I'm going to use -2. So -2, set up my synthetic division. The coefficients are 1, -3, 6, 2, -60. Drop the 1, multiply, get -2, add to get a -5, multiply to get a 10, add to get a 16, multiply to get a -32, add to get a -30, multiply to get a positive 60, add to get a remainder of 0. So by getting a remainder of 0, that means -2 is a solution. And if -2 is a solution, then the binomial factor is x plus 2. Because if I set that equal to 0, it gives me x value of -2. And then from synthetic division, because I just divided this polynomial by x plus 2, the quotient is what's left by synthetic division, 1x cubed, and I know it's cubed because it's 1 degree less, 1x cubed minus 5x squared plus 16x minus 30. Now there are 1, 2, 3, 4 terms. You could try to factor by grouping. It doesn't look like it's going to work. So if it's not going to work, do synthetic division again. You already used -2 synthetic division, but you can use 3 now. So I'm going to set up synthetic division. I'm using 3, and I'm going to try to fit it here. The coefficients are 1, -5, 16, -30. Drop the 1, multiply to get a 3, add to get a -2, multiply to get a -6, add to get a 10, multiply to get a 30, add to get a 0. So now I know that 3 is a root, is a solution of x-intercept. So the binomial factor that would give me 3 as a solution is going to be x minus 3. And remember, I already have that x plus 2, so that gets written down as well. And then from synthetic division, I'm left with the trinomial 1x squared, and I know it's squared because it's 1 degree less than what I just divided into, minus 2x plus 10. Now it would be wonderful if I could just factor this by hand. Of course, you can't factor it by hand, so we're going to have to do quadratic formula. Okay, if it could be factored by hand, you just factor it by hand. Once you get all the factors, remember the goal is to find all the zeros. So at this point, I know I can set this equal to 0 and I get a 0 of -2. That's one solution. Set this factor equal to 0 and I get an answer of 3. That's the other solution. But this, when I set it equal to 0, since it can't be factored, I have to do the quadratic formula. So the quadratic formula is that x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so x is equal to, plug in -2 for b, so it's +2 plus or minus the square root b, okay, -2 squared is going to be a 4 minus 4 times 1 times 10, that's a -40, all over 2 times a, which is 2. So that simplifies to 2 plus or minus the square root of -36 over 2. That's 2 plus or minus 6i over 2. Because these are both divisible by 2, you're going to divide and you get x is equal to 1 plus or minus 3i. Okay. So notice, here's one solution. Second solution, this is two different solutions, 1 plus 3i, 1 minus 3i. So that's a total of 4 solutions, which is what I said we should have since it's the 4th degree. Also notice if I pull up my graphing calculator again, that only 2 of our solutions are visible because -2 and 3, right? Those are your x-intercepts, your solutions, your zeros, but the other 2 are imaginary, so they're not going to be plotted on that x-axis, okay? All right, so that's problem number 1. Problem number 2. This one is a little tricky. I'll get you through it, but you set it equal to 0, and there are 4 terms. Also keep in mind, it is degree 3. So if it's degree 3, I'm looking for 3 solutions. Okay. Now for this one, I would typically try grouping, but it doesn't look like if I group the first 2 and the last 2, it doesn't look like I'll be able to factor, but watch what you can group. If I rearrange the terms and make it x cubed plus 125, and then I group the -3x squared minus 15x. And we typically don't have to rearrange when grouping. I don't usually get problems like that. This one, it just is helpful to do that because this is a sum of cubes. Sum of cubes factors to a binomial and a trinomial. We use SOAP for our signs, same, opposite, always positive, same, opposite, always positive. Cube is x, cube root is 5. Square this term, so x squared. Multiply these 2 together, 5x. Square this term, 25. All right, the GCF here is a -3x. When I factor that out, I'm left with x minus 5, or excuse me, plus 5. My common binomial factor is that x plus 5. So I have x plus 5 here. And then I have x squared minus 5x plus 25. Again, the goal is to find the zeros. Well, if I set this factor equal to 0, I know that one of my zeros, one of my x-intercepts is going to be -5. Unfortunately, if I try to set this one equal to 0, I can't factor it because there are not two numbers that are going to multiply to a positive 25 and add to a -5. So that means I have to do quadratic formula again for this problem. All right, just to give myself some room, I'm going to do quadratic formula over here. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So I have x is equal to, you plug in -5 for the b, so it's 5 plus or minus square root, 5 squared is 25, minus 4 times 1 times 25 is going to give you 100, all over 2 times 1, which is 2. So you have x is equal to 5 plus or minus the square root of 75 all over 2. All right. And that, did I make a mistake? Hold on a second. B. Why do I have an 8 in my notes? That was noisy. Hold up a sec. Oh, I forgot the G. I forgot this term. Oh no, guys, I forgot something. I just noticed, I don't know if you caught on to it. When I factored out my GCF, I totally forgot about this x. Backtrack, I apologize. The common binomial factor is x plus 5. That was correct. What's left over, I missed something. When I divide this by x plus 5, I'm left with x squared minus 5x plus 25. And whenever I divide this by x plus 5, I have that minus 3x. I missed that the last time. I'm sorry. All right, so combining like terms, I have x squared minus 8x plus 25. Just taking a look at my notes and I noticed that -8 instead of -5. All right, so this is still going to give you an x-intercept of -5, but my quadratic formula is going to be a little bit different. So trying that again, I have -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals 8 plus or minus the square root of 64 minus 100 over 2. So x equals 8 plus or minus, so make sure I'm not making mistakes before I get too much further into it. Nope, I'm good. 64 minus 100, yep. -36 over 2. All right, x is equal to 8 plus or minus 6i over 2. Both are divisible by 2, so I can divide, and I have x is equal to 4 plus or minus 3i. All right, so 2 solutions here, right? You have 4 plus 3i, 4 minus 3i, 1 solution here. And you're supposed to have 3 solutions. So there you have it. All right, we did not start off with easy problems this evening. Okay, let me see. Number 3, I think, is a little bit easier. So I think I'll do 3. And then number 4 is another one where you have to do the quadratic formula. So I'm not going to do that one because I think you've seen enough. All right, so for number 3, I'm going to set it equal to 0. Okay, there's only 3 terms, so I am going to see if I can factor this by hand. Let me think. How do we want to write this? Yeah, we're going to write this one, trying to do reverse FOIL. Okay, so x squared times x squared will give you x to the 4th. And we're looking for 2 numbers that multiply to 49 and add to a -48. So if I have a -49 and a +1, that'll multiply to -49, but add to a -48. Okay. And then from there, you see if you can factor any further. There are 2 terms, but this is a difference of perfect squares. So it factors to x minus 7, x plus 7. And then this one is not a pattern, so it stays as x squared plus 1. Now that they're completely factored, you can set each factor equal to 0 and solve. X squared plus 1 equals 0. So you have x is equal to a positive 7, x is equal to a negative 7. Here I'm going to have x squared is equal to negative 1. X is equal to plus minus the square root of negative 1. X is equal to plus minus I. So you have two solutions here, positive I and negative I, and then a third solution and a fourth solution, which makes sense since it is a degree 4 polynomial. All right, so just as kind of a quick little recap, if your polynomial is 3 terms, you try to factor it the way we always do. Reverse FOIL, guess and check, or move on to quadratic formula if it can't be FOIL by hand. If your polynomial has 4 terms, try grouping. If grouping doesn't work, then do synthetic division. To figure out what numbers to use for synthetic division, we plug the function into our calculator, we graph it, and we look at the x-intercepts. And those are the values we use for synthetic division. If there are more than 4 terms in your polynomial, then you have to use synthetic division. And you might use synthetic division more than once, like you saw in the first problem. Okay? All right, let's erase and move down. Okay, we did a bunch of these examples in the last lesson as well. So I think I'm just going to do 7 and 8. So for 8, if 8 is a, 7, for 7, if 8 is a solution, that means the binomial factor is x minus 8. And then if 3 minus I is a solution, so is 3 plus I. I'm going to do the sum and product rule. Okay, 3 minus I plus 3 plus I. The i's cancel. Your sum is 6. 3 minus I, 3 plus I. FOIL it. You're going to get 9 minus 3i plus 3i minus I squared. The middles cancel. 9 minus negative 1, that's what I squared is equal to. That's going to give you a product, of 10. So you have a sum of 6 and a product of 10. So that means that we write it as x squared minus the sum x plus the product of 10. After you get that, then you just have to multiply it all together. Distribute the x in, so I have x cubed minus 6x squared. F, so it's just f of x equals x to the third minus 14x squared plus 58x minus 80. There we go. Okay. All right, and the last one, number 8, that I'll do from this section. So if 0 is a root, that means that there is a GCF of x, all right? If 2 minus root 1 is a solution, 2 minus, or sorry, not root 1, root 2. 2 minus root 2 is a solution, so is 2 plus root 2. So I need the sum and the product of those. So the sum, 2 minus root 2 plus 2 plus root 2, the root 2's cancel, you get a sum of 4. The product, 2 minus root 2, 2 plus root 2, you're going to have 4 minus 2 root 2 plus 2 root 2 minus root 4, the middles cancel, so 4 minus square root 4, 4 minus 2, which is a 2. Okay, so I'm going to do the work over here just so this, again, the 0 gave me a factor of x. And then the sum and product rule for the 2 minus root 2 is going to be x squared minus the sum, which is 4x, plus the product, which is 2. All right, I have to do one more, right, because I have another solution. If 2 plus 3i is a solution, so is 2 minus 3i. The sum, you're going to have 2 plus 3i plus 2 minus 3i. The 3i's cancel. You get a sum of 4. The product, you're going to have 2 plus 3i, 2 minus 3i. 2 times 2 is 4, minus 6i, plus 6i, minus 9i squared. Middle terms cancel. 4 minus 9i squared. I squared is equal to -1. It's 4 plus 9, which is going to be 13. So now I have another polynomial factor of x squared minus 4x plus 13. All right, the last step for this problem is to multiply it all together. All right, I'm first going to distribute the x in. So I'm going to have x cubed plus 4x squared plus 2x. And I'm multiplying with x squared minus 4x plus 13. I have to distribute x cubed to all three terms, then a -4x squared to all three terms, and then finally a 2x as well. Okay, so I'm going to have x to the 5th minus 4x to the 4th plus 13x cubed. Okay, now move on to the -4x squared being distributed. -4x to the 4th plus 16x cubed minus, what would that be? 20, so I can't do math in my head tonight. 52, is that right, guys? Yeah, 52x squared. I shouldn't be doing this math at 10 o'clock at night. My brain is fried, so I apologize if I'm making silly mistakes, because I know I am. Distribute the 2x into the parentheses. So I have a positive 2x to the 3rd minus 8x squared, and then a positive 26x. Okay, combining like terms, as long as I didn't make any mistakes, it's going to be x to the 5th. There are 2x to the 4th term, so it's -8x to the 4th. Then 13x to the 3rd and 16, that's going to be 29. And then 29 plus another 2, 31x to the 3rd. And then I'm going to go to my x squares, -52 and -8. I think those are the only two. So it's a -60x squared. And then a positive 26x. Again, make it f of x equals, and there is your polynomial function of least degree that has those as its solutions. All right, that was a crazy one. Okay, next. Let me see. Find the zeros of the function, sketch the graph of the function. All right, I'm just going to do one of these because these are actually review problems. I didn't mean to put them in the notes. I'm just going to do one of them and then we'll be done. All right, so finding the zeros of the function, I'm going to set it equal to 0, x to the 4th plus x to the 3rd minus 12x squared. Only 3 terms. Look for that GCF to start. X squared is the GCF. So I have x squared plus x minus 12. All right, then I'm going to try to factor by hand. So hopefully I don't have to use quadratic formula. What are 2 numbers that multiply to -12 that add to a positive 1? It's going to be a positive 4 and a -3. Okay, so I have x equals 0, and that's a double root. I have x equals -4, and I have x equals 3. Okay, notice there are 4 solutions, 1, 2, 3, 4. and it is a polynomial of degree 4, okay? Degree of 2, remember, look at the factored function to talk about pass versus touch. Degree of 2 means that I'm going to touch, even degree of touch. Degree of 1, odd degree of pass, and pass. Okay, end behavior is the last thing we have to talk about. So the end behavior for this, because the polynomial function has an even degree, is treated like a quadratic where both ends are up or both ends are down. To determine which one, we look at the lead coefficient. It's positive, so I know both ends are up. All right, so I'm going to plot the x-intercepts at 0, -4, and 3. The ends are both up. We said that it passes through -4, it touches at 0, and it passes through at +3. I actually think we actually did all of these problems in a different, maybe they weren't the same in one of the earlier lessons, because these are just review. All right, guys, so that is how you work with these graphing problems. If you're looking for more practice, feel free to work on, Feel free to work on problems 10 and 11. You can always come to Google Classroom if you want to ask me if you did them right, or if you want me to do them with you, okay? But they're all done by factoring. You don't have to use synthetic division for any of these, all right? So that is it for lesson 4.6. And I will see you for the next lesson later on. Bye.